Hello there. Welcome to CXC Math TV. And today we're going to be looking at linear inequalities. That's our topic for today. Linear inequalities. And we'll be looking at solving and also graphing linear inequality. And when we say graph, we're talking about the number line. That is something we would have learned from prep school and primary school. All right, let's go ahead and look at linear inequality. So first we have to review what is an inequality. And an inequality, it simply just gives us a range of set of values. It gives us a what? A range of set of values rather than just giving us one number. All right, and so in other words, it's an algebraic relationship showing that a quantity is either greater than or less than another quantity. And that's it. That's all is an inequality. That is all. All right, so for example, speed limit, right? So maybe you're driving and you're going somewhere and they tell you that you should be driving somewhere between 55 to 75 miles per hour, maybe on the highway, right? And they say speed limit, you shouldn't be going faster than 75, but you shouldn't be going slower than 55, right? And so this right here is an example of an inequality. So any number between 55 and 75 is good, all right? So now in inequalities, there are some symbols that we must know. These are the four symbols. You must know them. You must do what? Must know them. The first one, less than symbol right there. All right. The second one, greater than symbol. The third one, less than or equal to. And the last one is greater than or equal to. All right. So let's look at each symbol. So for example, as we said, you can have a range of answers, right? With linear inequalities. First thing is this is a number line, right? We're trying to connect the two, so we appreciate what we're doing. So for example, if we put a mark right there at the point where the value is 2, right? And we bring the arrow to the left. Notice in red, we're going to the left. So we're looking at numbers that can be 2 or less, right? We're looking at numbers less than 2. So like 1, 0, -1, -2, -3, -4, and so forth. Our solution then is x is less than 2. Look how we write our answer in inequality form. X is what? Less than 2. So this number line represents all the numbers, all real numbers less than 2. That's it. That's how we use the less than sign there. Now let's have a look at another one, right? We can put a number this time at -2, but let's this time go to the right. How do you think we're going to write that one? First thing, what are the numbers we're looking at? We're looking at numbers bigger than -2. So put what? X greater than -2. That's your number line to represent this inequality. Let's continue. So look at this now. Big difference. This time we put a shaded dot. Notice this is shaded, right? And then let's say the arrow is going to the left. So we're looking at numbers less than 1, but because it is shaded, we write all the numbers less than or equal to 1. So once it's shaded, it's less than or what? Equal to. That would represent x less than or equal to 1. Continuing. Right there, we see that it is shaded again, and we're going to the right. So we're looking at numbers bigger than -3. Bigger is what? Greater than. So again, we're going to put now x greater than or equal to -3. And that is it. Easy. Number line, easy so far. Now, did you notice anything from the solutions, right? So just to bring up two right there. One was open and one was closed. Look at the one that was open. Look at the one that was closed. All right. So again, if the symbol is greater than or less than, then the dot is open because it is not equal to that. That's what we should take away from this. So like example one right here, just an open dot, right? It is not shaded. And if the dot is shaded or it is solid, then you know that it should be greater than or Greater than or equal to or less than or equal to. Key thing to remember, please. Remember then, shaded meaning use what? Greater than or equal to. And then when it's open, right, you use strictly less than and strictly greater than. Now, this is just an example in real life right here, right? So maybe it says Ronaldo. I just shorten it to call myself Ron. So Ron ran a 2K in 8 minutes. By the way, I'm faster than that. It's just an example. So Ron ran a 2K race in 8 minutes. Write an inequality to describe the average speeds of runners who were faster than Ronaldo. Graph the inequality. Alright? By the way, we know no runner would be faster than Ronaldo. I'm just kidding, I'm not the fastest. So in this example now, right? First thing we're looking at average speed. Average speed is what? Average speed is total distance divided by total time, right? And so when you do the division, right, you divide 2K divided by the 8 minutes, right? So you get a quarter, all right? So I put the 2K there over 8 minutes. So the average speed is, Ronaldo is running every kilometer in approximately 4 minutes, right? A quarter, right? And so persons who are running a kilometer in faster than 4 minutes, right? Those persons would be faster than Ronaldo. So right here it shows it, right? So those who are running faster kilometers, you know, that is that. Okay. So again, oftentimes in an exam, you're gonna get like, an inequality and you're gonna have to solve for the range of x. You're gonna have to isolate the variable. And we isolate the variable and it is bold, put in red and bold for you. To isolate the variable, you perform the inverse operation, right? So for example, if you see x minus 3 is less than 5, the inverse operation is addition. So you'd add 3 to both sides, and then you'd end up get x is of course less than 8. Is less than 8. Alright, and that's all. Alright, so notice we isolated to finally get the range of values for x. Again, it don't have to be just addition. What about subtraction? So let's say x plus 6 is greater than or equal to 10. Because it's a plus 6 right there, we need to remove that plus 6 away from the x. So we subtract 6 from both sides. And so we get x is what? Greater than or equal to 4. Alright? Really nice. Now, what if we saw x plus 5 greater than or equal to 3? And it says graph the solution. First thing we do is what? Subtract 5, right? We'd had to I want you to do this for me. So pause the video and do it. I didn't put in the solution because yes, I remember. I wanted you to pause the video and do it. So graph the solution of x for this one. Alright, so as you do this, the first thing we have to do is subtract 5 from both sides. And so we'd end up get x greater than or equal to 3 minus 5 is negative 2. So this is it. So first we draw our circle at negative 2. Right? And we need numbers greater than or equal to negative 2. So the arrow is pointing this way. But guess what? What do we know? What we know is since it's greater than or equal to, we have to shade. We have to bold our circle. And that's it. Really nice. Okay. What about this one here? Minus 2 is greater than n minus 4. Graph the solution for that, please. Pause the video and attempt. Alright, so as we attempted, the first thing we realize is that we have to do what? Add 4 to both sides. So we can get n by itself, and 4 minus 2 plus 4 is 2, so 2 is greater than n. But imagine, I can say, look what I'm saying, I can say Imani is taller than Jarell. And it's the same as saying Jarell is shorter than Imani. So in other words, I can rewrite 2 greater than n as n less than 2, right? As long as it's still facing the 2, we're good. So now that we have n is less than 2, We draw a circle at 2 and we need numbers less than 2, so we're going to the left. This is our solution. Alright, graphically. Really nice. Notice we didn't shade it because it was strictly less than. Nice. Now here's a trick now, the trap. So whenever you're dealing sometimes where you have the variable being negative, when you multiply or divide an inequality by a negative number, you have to reverse the inequality symbol to maintain the statement to be true. So follow what we're saying. What we're saying is if you're solving using multiplication, right? And you multiply through, look, with positive terms, it's easy. If we have half x is greater than 3, if a half of x is greater than 3, you'd multiply both sides by 2 to get x must be bigger than 6, right? Because if half of x is bigger than 3, when you double it, then x itself must be bigger than 6. Makes sense. We got our solution by multiplying by 2. Now, here's the thing. Look at division now. 3x is less than or equal to 9. We can clearly divide both sides by 3 to get x isolated, to get x is less than or equal to 3. Again, notice that the inequality is still true. But here's the troublesome part as we're saying. What about a statement like this? Negative x is greater than 4, right? And we want the solution region for x. If you go ahead and multiply both sides by -1, -1 times x give you x. But the key thing, here it is, only going to say it once. The key thing is when you multiply by a negative, to show that you multiply by a negative with inequalities, you reverse the inequality sign. You do what? You reverse the inequality sign. That's all. You flip the inequality sign. Easy. See the switch, please. Remember it, please. All right. In the same way when you're multiplying, also when you're dividing by a negative, you also change inequality sign. So if negative 2x is less than or equal to 6, and you divide out -2, then in that case, x is greater than now or equal to -3. I left off the -3 right here. Sorry about that. -3. All right. Please. Now, here are some questions that you typically see on exam. So I want you to pause the video and attempt all of these questions now, solving linear inequalities. Then we'll go through them together. So pause the video, attempt the question. All right, so looking at the first one now, 5x minus 8 is greater than or equal to 36. The first thing we need to do is what? We need to isolate x. Isolate x, we can do what? Add 8 to both sides. And by adding 8 to both sides, we get 5x is greater than or equal to 44. Now, since we need x, we do what? We divide both sides by 5. We divide both sides by 5. We get x is greater than or equal to 44 over 5, or some might say x is greater than 5 into 44 goes 8 times, so x is greater than 8.8 because the remainder would be 4 over 5. So that's our answer there. X is greater than or equal to 8.8 for part A. Part B. Part B is 8x is less than 18. And so the first thing we do is we divide through by 8. When we divide through by 8, we get x is less than 18 over 8. If you put 2 into it, 9, 2 into the denominator 4. So x is less than 9 over 4. Or some might say x is less than 2.25. Easy. Third one. We have 7x minus 1 is greater than 58. So we add 1 to both sides first. We have 7x is greater than 59. And then we divide both sides by 7. So we get x is greater than 59 over 7. And 59 over 7 is 7 into 59 goes, is that 8 times? 8 and 3 over 7. So somewhere about 8.4. X is greater than somewhere about 8.4. Wow! Part D. 10x minus 18 is greater than or equal to 82. So we do what first? You do what? Add 18 to both sides. So that becomes 10x is greater than or equal to 82, and 18 is 100. And so now, in order to isolate x, we divide both sides by 10. This 10 cancel this 10, so x would be greater than or equal to 100 divided by 10 is 10. That's our answer. X is greater than or equal to 10. So much fun and so easy. Part E. Part E now is the challenging one. So I want you to, yes, pause the video again and attempt part E. Pause the video and attempt part E. So the first thing is we need to make x on one side and the numbers on the other. So we can subtract 7x first from both sides. And while we subtract 7x, we also need to subtract 4. And by doing that now, 9x minus 7x leaves 2x. 4 minus 4 gone is greater than 15 minus 4 is 11. So we get 2x is greater than 11. Then we just do what? Divide both sides by 2. So x is greater than 5.5. And that's our answer. This is so easy. Hey! Now we need to express our solutions graphically because it says now represent the solution of each on a number line. So let's put up our number line. I remember we did part A, and part A was something like x is greater than or equal to 8.8. So let's do our number line. Let's go with 0, -1, -2, -3. Alright, let me not use these set of values. I'm just going to change the scale. I'm going to write -2, -4, -6, -8, -10, 2, 4, 6, 8. So this is for question 1, right? And this is 10. 8.8 is somewhere here, right? Somewhere there is 8.8, but we don't want to shade it, right? We don't want to shade it. We don't want to shade it, right? So remember, 8.8 is right here. That's 8.8. And we want when x is greater than or equal to 8.8, so we'll just draw our arrow that way, right? And that would be our number line. Easy. Nice. Question 1. Question 2 was something like x is, I think this, so this one was when x is greater than or equal to 8.8. I think we got this one to be x was less than 2.25. So drawing the number line again for question 2. Right, let's put on our numbers 0, -1, -2, -3. Over here is 1, 2, 3, and so forth. Now 2.25 is somewhere here, right? Oh, I didn't shade it. So down here now, because we want strictly less than, we're not going to shade it. So just draw a circle and we need less than. Draw an arrow that way. And that is it for question 2. Easy. Question 3. Question 3, I think this one, the solution was something like x is greater than 59 over 7, which is 8 point something. So in that case, again, let me just start with 2, 3, 4, 5, 6, 7, 8. Alright, I'm going to clear this and make a better scale. Try to make some good scales for me, please. So 5, 6, 7, 8, 9, 10. So we want 8.8 and 3 over 7, somewhere about here. And we're what? We're strictly greater than. So we draw our arrow that way. And we don't business about the numbers over here. Easy. Nice, that's your number line. Number 4, I think the solution we had got was x is greater than or equal to 10. And so in that case now, for question 4, drawing our number line, right? So we want x greater than or equal to 10. So you can put your label. I'll start with 7, 8, 9, 10, 11. Over here we have 6, 5, 4. To be greater than 10, we're going this way. That's our number line. And the last one, question 5. Pause the video and do the number line for question 5. If you remember the answer. So if you go back, we had gotten x is greater than 5.5. We need to represent that on the number line. So draw a number line. This is 5, 6, 7, 8, 4, 3. And we need greater than 5.5. 5.5 is in between 5 and 6. Greater than, so we draw it that way. And that is it. Easy. Soft. Okay, now sometimes they'll ask you questions in this form. Alright, so sometimes they'll give you questions in these forms where it's way more challenging. So guess what? I'm leaving you with homework. Your homework is to find the smallest values that x can be to satisfy these inequalities. And after you do that, then you represent these on a number line. So try it, try it, try it. Alright, try it. And I hope that this video was helpful and that you can use the basics to attempt these more challenging questions.